So let us consider the probability P of xy, which is jumping from x to y. So for these, the first one, the step number 1, that is a proposal density must generate y. Okay. So if you're generating the observation from y, and the second step, you must accept y. So if you're generating y and you're accepting y, then only you may get the probability of jumping from x to y. Okay. If you're generating from jumping from x to y, so this probability will be getted by generating y from the proposal. So use the proposal density. You are generating from the proposal density, that is, you're generating y observation. Okay, given the xt is your seed value, into you are accepting that probability. So it is a alpha x comma y. Okay, so it's q of y given x into alpha of x comma y. So q of x comma y comma y given x, and this alpha x comma y you have already obtained. So you can substitute here, and now this y given q of y given x, q of y can get cancelled. So you are left with f of y upon f of x into q of x given y. So what we have observed, f of x into p of x comma y is same as f of y into q of x comma y. I think we have written both here, p p. Yeah? Okay, just change here. It is slightly correction. So okay. So this is say this is 1. Similarly you can write for p of y comma x, right? So p of y comma x, that means you're jumping from y to x. So what happened, y to x? So proposal density distribution generate x, and we must accept x. So what will be y given x? Y of x given is same as, it must generate x. So x given y into alpha time y comma x, right? Alpha of y comma x. This is nothing but your q of x given y, proposal density of x given y. So similarly, as you did it here, you can do it for this one also. So this same expression you may get here also. So which is f of y into p of y comma x is same as f of y into q of x given y. Now if you just look at here, f of y q of x given y, f of y q of x given y. So right hand side is same, and hence one can say that your left hand side is also same. So from 1 and 2, one can observe that f satisfies the detailed balance equation. So what is that? What is that? F of x into p of x comma y is same as f of y into p of y comma x. So these both are satisfying, and so these both equations, number 1 and 2, both are same because of right hand side is same, and hence one can say that your f is a stationary distribution because of it satisfies your detailed balance equation. Okay, I hope I am not very fast, but you can go through this again. There's no problem. You can take your time also, understand the concept, how it is worked, because it is going to be asked for the theory part and as well as in practical also. So you have to understand the concepts and all. Okay, so it will be not immediately come, because it is required a practice and then practice and then practice. You'll be get it done otherwise. So just go through for the 5 minutes, then we will. So let's see how one can able to solve the problem based on Markov chain. Okay. So what you need to do here, just look at here. So let's write down first derivation part of this. So f of x is nothing but, which is your target distribution. It's 1 upon pi 1 upon 1 plus x square. So this is a Cauchy distribution, right? So this is your target distribution, and here you may observe the range for this x is minus infinity to plus infinity. Okay, so that's why we are considering here the proposal density. Proposal distribution is my normal only, because the range will be x comma minus infinity plus infinity. Okay, so that's why you have to consider the normal will be as my proposal distribution. Okay, so these two distributions are given to you, which is supposed to be given, otherwise you cannot consider. Everybody will consider a different proposal, and then it's going to be difficult. Okay, so what you have to do, first of all, we need to compute alpha x comma y, which is the minimum of your f of y into q of x divided by f of x into q of y given x comma y. Okay, remember x comma y. So when you say x comma y, then f of y into q of x given y, and इसका reverse लेने का यहाँ. Okay, so comma y. So this quantity we need to create when we need to compute this quantity. So you can just substitute the values here in terms of y. This is in terms of x. Okay, similarly here, so you can substitute. Now this is your proposal. Sorry, this is your target in terms of y. So wherever x you replace by y. So it's 1 upon 1 plus y square f of x. So which is going to be same. Divide करना है. Similarly, q of x given y. So q of x given y. Q of x given q of y given x. So you can q of saying y. तो चेंजेस क्या होगा, ये y given x है तो यहाँ पे मैं y minus x लिखता हूँ, x given y है तो यहाँ पे x minus y लिखता हूँ. डिफरेंस इतना ही है यहाँ पे. Okay, the rest will be same. So whatever term is getting cancelled, you cancel it, because this is going to be same, because x minus y or y minus x, it is in square, so it is going to be the same. So everything get cancelled, we left with this expression, right? So we got alpha x comma y is same as the minimum of 1 plus x square divided by 1 plus y square comma 1. Okay, so this will give you the alpha x comma y. Now what is your MH algorithm? What is the MH algorithm? How you generate, how you write the algorithm? Generate y from the normal xi comma b square. So as I said, you have to generate, if you just remember the MH algorithm, generate y from the normal xi comma, that means you have to generate from the proposal. So you're generating y observed from the proposal and generate from uniform, and if this condition true, if xi plus 1 is same as y, if u of alpha xi comma y, that means if my generated observation is lesser than this probability at xi comma at this y, and if it is more, then it will be again my xi only. So you have already generated xi, so it will be the same. That means you are not accepting this y value, and this sequence we will continue till we get the desired result. Okay, so you can just work this simulation part. You can just run and see whether it works or not, and then we will discuss, might be the next class, how it works. So we can consider the example of algorithm. Let me explain this first, and then we will go to the R code. So you are generating the 10,000 observations, okay, and now you're creating a vector x and y, because here we have to create a two vector, one for the x, one for the y. Y is your proposal density. Okay, if you just consider b is equal to 0.1 and a seed value, the x first value will be 0.1, which is very near close to your mode value. Okay, we will just consider, because it is it is the centered at 0. Okay, the mode is 0, we consider it is 0.5. Okay, now just create a loop. So first, what is the first step? We generate y from proposal. Okay, we generate y from proposal. If you're generating y from proposal, and then you generate u from uniform, and just check this condition. If this condition true, then you consider generated observation is your xi plus 1, If not, then it is xi. If u will be less than equal to alpha of xi comma y, then generated observation is same as your xi plus 1, otherwise your xi observation. Okay, so let's see. So look at this, y of I generating from the normal, because y is proposal is normal, proposal from the normal 1 comma xi comma b, you are generating u from uniform, right, with 0 comma 1, and then you are obtaining r is your alpha value here, acceptance ratio value, minimum of 1 plus xi square, which you have calculated here. Look at this is the alpha value, ratio value. Okay, so this you are writing, so it's a minimum of this quantity comma 1. So minimum of 1 plus xi power to r divided by 1 plus y power to 2 comma 1, because if you take minimum of, subtract the values, right? This is your x square upon y square comma 1. Then you calculated this value. Now I have to check the condition. So xi plus 1 will be, so I'm just saying that this value will be true if this condition true, right? So xi plus 1 is equal to, if else this condition true, then this value, otherwise this value, ऐसे लिखना है. So if else this value, this condition true, comma, this value is correct, otherwise this value will correct. So मुझे ऐसे लिखते, we have to write in that fashion. So if else u is less than equal to r, then ith value of yi my value, otherwise it will be x ith value. And then you can just draw the plot, you can just look at the histogram and how it works. Okay, so that part you can observe and you can try to get that. Okay, that is not much easy that not very difficult part, that you can observe and you can try to get it. But only the thing is here, when you come to the plot of this, because you're generating the observations, okay, so definitely there will be the dependency in the data set. Definitely there would be the dependency in your data set. So to remove that, we are required the autocorrelation little concepts. Okay, so how we can check that whether your data will be dependent or not. So for that you need to be just check autocorrelation plot. Okay, and how it works, when you exact do it in your R studio, then only you will be visualize that how it works. Okay, it's a little take time, but you can go through it. Okay, there's no problem with that. So you can just go through these concepts again here. Then we'll move to the R code of this. You will be not understand this concept in one attempt. Okay, so you need to be just go through and go through and go through till you understand. So I think you should go through first the material I have shared with you. Okay, then we will continue.